Well, greetings, everyone. And again, thank you, Sarah, for such a great kickoff a few minutes ago. And I know all of you got your next cup of coffee. Again, greetings from Geneva, Switzerland. Joel Meyer here with the Pacific Disaster Center. And so great to be a part of this event. And although we're not all in Amsterdam for this event this time, it's so great to have our global community. And joining us today, one of our curtain raiser from, again, the Startup Showcase. What's so exciting, I have the privilege of introducing Mr. Kees, the co-founder and the CEO of Syntho. And in doing some of my research and catching up with him a few minutes ago, I think it's really exciting that he's going to be talking about providing trust in data-driven innovation. This idea that AI can generate synthetic data, and I think that's such a great advent in technology, this idea from training data to innovation. So if you have any questions for Wim after his presentation, please head over to the Q&A lounge that will be taking place in the Sessions tab. So click on the Sessions tab, and you can post your questions and chat, go live, whichever you prefer. So with that in mind, Wim, the stage is yours. Over to you.
Yes, thanks. And always nice to kick off a session with such an amazing introduction. So yes, welcome to my session about providing trust in data-driven innovation with synthetic data. And in this session, I would like to demonstrate why classic anonymization techniques do not result in anonymous data, why synthetic data is different, and how this provides trust in the realization of data-driven innovation in practice. And in the end, I would like to inspire you all to start using synthetic data as alternative to using original data. So let's start with big data, because I think this was one of the promises of last decade for innovation. But now in 2020, we only see a small part of this promise realized. So why hasn't big data fully delivered yet? And one key reason is privacy. And privacy is not only the heart of our free society, it also affects companies. It can damage their reputation, clients can leave, and causes penalties. Yes, privacy hinders data-driven innovation. And we need a solution for this dilemma, right? Ideally, your innovation manager and your compliance officer will become best friends. Now, let's go back to that classic anonymization techniques. So, classic anonymization techniques offer no solution since they cannot fully mitigate privacy risks and destroy your data. But why is this the case, and what do we exactly mean with classic anonymization techniques? To start, with classic anonymization technique, we apply all methodologies where one manipulates or distorts an original data set to hinder tracing back individuals. And examples of those techniques that you might recognize from practice are pseudonymization, wiping, data deletion, generalization, and row and column shuffling. But why does this not work in practice? And let me illustrate this with an example dataset that contains customer data. So, as you can see in this example, it's a simple version of a typical client dataset. And in the first row, we see Olivia. She's 26 years old and bought shoes on 4 March for a price of 125 euros. So, typically one starts with removing various attributes from the dataset. And as you can see here, the names are simply removed from the dataset. And while some already stop here with applying classic anonymization techniques, others continue. So in this example, we see generalization. Olivia, being 26 years old, is now placed in a bucket ranging from 25 till 30. And of course, one could continue applying those techniques on the dataset. And note that one thereby also continues to destroy the data. And this is really what happens with those classic anonymization techniques. The data value of the dataset is destroyed, and this is a big disadvantage if you would like to use the data to realize data-driven innovation, for example with AI. But there is still another disadvantage. The second disadvantage is that one will always have a privacy risk. And this is due to the fact that there will always be a one-to-one relationship between the original data and the data with applied classic anonymization techniques. As you can see in this example, Olivia of 26 is still in the anonymous dataset. It is only slightly harder to trace her back, but the risk of a linkage attack is always there. And the main question, how big is the risk of a linkage attack? So let me illustrate with this example. The researcher named Sweeney demonstrated this in an academic paper. She showed how she was able to identify and retrieve sensitive medical data from individual databases by linking public available data sets of hospital visits to a publicly available voting register from the United States. And note, both data sets were assumed to be properly anonymized through the deletion of names and other direct identifiers. So what did she find? Based on only the 3 parameters, zip code, gender, and date of birth, she showed that 87% of the entire US population could be re-identified by matching aforementioned attributes of the datasets. Then Sweeney continued to this by removing zip code for the place. And additionally, she demonstrated that when used the place, 53% of the entire US population could be identified. And finally, Sweeney repeated her work with having country as alternative to the zip code. And here she demonstrated that 18% of the US population could be identified. And why is this so important? It demonstrates that it can be remarkably easy to identify individuals in a seemingly anonymous dataset. Only having access to 2 or 3 attributes might be already enough to trace back an individual. So, anonymization techniques do not only destroy your data, those classic anonymization techniques also do not result in anonymous data. And to get to our solution, I want to ask you this question. Take a look at the 3 images in this slide. Which of these 3 images do you think is fake? They're all fake. The faces you see here do not exist in the real world. These are synthetic images generated by artificial intelligence. And although AI and privacy are often put as opposites, we believe this technology can be used for good. And this is one of the core beliefs at Syntho. AI and privacy should be allies instead of rivals. What if one does not need to choose between data and privacy anymore? And what if this generative AI that we just saw with the images could be applied on stricter data sets? And this is exactly what we do at Syntho. Our Syntho engine is trained on the original data and generates a completely new and anonymous synthetic data set. And what makes us unique, we apply AI to capture the value of the original data. And the bottom line, our synthetic data is highly realistic and can be used as if it's real data, but without those privacy risks. And the key question here is, how is it different compared to those classic anonymization techniques? So, first, there is no one-to-one relationship between the original data and the synthetic data. Olivia from 26 that bought shoes simply does not exist in the synthetic dataset, nor any of her corresponding attributes. And second, on dataset level, we are able to generate synthetic data in such a way that we preserve the patterns, relations, and statistics. In other words, we generate synthetic data that can be used as if it is real data, but with preserved quality. And the key question is, how good is that data quality? So we offer a quality report for every generated synthetic dataset to demonstrate this. And let's take a look at what's in this report. So let's start with the distributions. They give insights in the frequency of a certain data record for a given category or value. As can be seen in the following graph, the distributions for the original data in gray and the synthetic data in blue are nearly identical. And correlations provide insight in the degree to which 2 variables are related. And also here we see that the correlation matrix for the original data and the correlation matrix for the synthetic data are nearly identical. And we can also take this one step further. So where univariate distributions and correlations provide insights in the distribution and relationship for a single category, multivariate distributions provide insights for combinations of categories and are also captured by the Syntho engine. Again, we see similar results. And the ultimate test is to train a machine learning model on both the original data and the synthetic data and compare the outcomes. And even in such an ultimate test, we observe similar results. And this shows that synthetic data retains statistical properties to such an extent that even machine learning tasks can be applied on synthetic data as alternative to using the original sensitive data. And next to the superior data quality and privacy protection, there's another feature. as a result of not having one-to-one relationships, one is able to generate an unlimited amount of data. In this example, suppose the original data set contains 100,000 records. One can simply decide to generate a synthetic data containing 800,000 records. And therefore, we always ask this question: why use real data when you can use synthetic data? And this is our answer. First, you can minimize personal data and thereby reduce, for example, data breaches. And second, you can unlock personal data that was restricted due to privacy. And to summarize, synthetic data allows you to build a strong foundation to boost data-driven innovation with less risk, more data, and faster data access. And this unlocks a wide variety of use cases that could boost the realization of data-driven innovation. But let me illustrate data sharing. Highly sensitive customer data is typically collected in any corporate and cannot simply be shared internally or with third parties. Consequently, those corporates cannot realize data-driven innovation, for example, with AI. And our solution is share this data in synthetic form to guarantee both the data quality and the privacy protection. And the benefits for those corporates: less risk, more data, and faster data access. After our visit, those corporates can test, develop, and innovate with synthetic data. And I see you all thinking, can we already use this? Yes. If you're interested in our solution, please contact us via email or visit our website, or do the synthetic data scan at syntho.ai/scan. And via the scan, we help you to explore the potential value of synthetic data for your organization. So why use real data when you can use synthetic data? We are Syntho, and we solve your privacy dilemma. So,
greetings, Wim. This is Joel in Geneva, and on behalf of the Inspired Minds team and for all of those that are concerned about data privacy, I think that was such a compelling overview. I can tell you at so many levels throughout the United Nations, my work at the CIO level, and that B2B corporate to corporate discussion that you had is so very compelling. So with that in mind, I want to thank you again. And for our colleagues, you can learn more from Wim's work and to his team at Syntho. You can join him in the networking lounge, the speaker Q&A room. So there'll be a link that'll be in the chat. So if you want to take a look in the chat there on Hopin. And again, we're going to take a quick break, and then we're going to go on to our next speaker. Wim, thank you so much. Again, we really appreciate your work, and what an exciting time to look at synthetic data, ensure privacy, scale as well. So again, thank you all, and we're going to take a quick break. Aloha.